talk about the electronically controlled 4-speed automatic transmission offered on some Volkswagen models. What we'll cover in this tape is a brief overview of the transmission, its mechanical operation, the external controls to the transmission, and checking the ATF level. The VW 4-speed automatic transmission, identified as the 096, is a compact design transmission capable of handling high torque loads. Eventually, this transmission will replace the 010 3-speed transmission currently in use. The transmission features a spin-off oil filter in addition to a serviceable filter screen in the oil pan. It also has an oil cooler that uses the engine coolant to cool the ATF. While the torque converter looks pretty conventional, there's an ingenious way it is bridged during third and fourth gear operation. Power is transferred directly from the engine to the transmission gears with no hydraulic torque multiplication. We'll take a look at this in detail a little later. The transmission electronic control unit, located under the rear seat on Passat models, controls all the shift points for the 4-speed operation. This means that you can use the 1551 to check the fault memory using rapid data transfer. You can also use the 1551 to check ECU inputs and return the ECU to its basic setting. Even though the transmission is electronically controlled, it is still possible to drive the vehicle if an electronic problem develops or even if the ECU is disconnected. If a problem does occur, the vehicle can be driven without the electronic controls in manual first, third, and reverse. When operating in this emergency mode, the transmission will operate in third gear no matter what forward selector lever position you've chosen besides manual first. In normal operation, the driver has a choice of 2 driving modes that can be selected with this switch, economy and sport. When the transmission is in economy mode, the shifts occur at lower engine RPM. This conserves fuel. For more sporty driving, sport can be selected and the transmission will shift at higher engine RPM. Automatic shift lock will be used with this transmission. The selector lever can be moved from park or neutral positions only when the brake pedal is pressed. At speeds over 3 miles per hour, the driver can move the lever from N to D without stepping on the brake pedal. There's a 1-second delay in the shift lock system that allows you to rock the vehicle if it becomes stuck in snow or sand. This would be a good time to go to the vehicle and familiarize yourself with the 096 transmission. Look at its installation in the vehicle, locate the ECU, and check the operation of the shift lock. Let's take a quick look at the mechanical operation of the 096 transmission. The engine torque is transferred to the transmission gears via 2 shafts, the turbine shaft and the impeller shaft, depending on the gear selected. 3 driving clutches and 2 holding brakes are supplied hydraulic pressure to determine how power is distributed to the Planetary gear set where the gear ratios are determined. A ring gear cut on the outside of the Planetary gear set provides output to the final drive. The power from the ring gear to the final drive assembly is transmitted via an intermediate shaft. Let's go back and take a closer look at the mechanical operation of the 096. Power is transferred from the engine to the transmission via 2 shafts, the impeller shaft and the turbine shaft. The torque converter looks and operates pretty much like the converter in any automatic. It has a stator and roller clutch. Anytime torque is being multiplied in the torque converter, like during acceleration, the turbine drives this turbine shaft. What's unique is that during third and fourth gear operation, This shaft is connected directly to the torque converter impeller via clutch K3. This means that the power from the engine is transferred directly to the planetary gear set, and there is no torque multiplication or slippage in the torque converter. You've actually bridged the torque converter. Remember that the impeller shaft is driven directly through the torque converter and turns at engine crankshaft speed. These two lugs on the torque converter hub drive the ATF pump. The ATF pump is a gear-driven crescent-type pump. The lugs on the torque converter engage the pump here, so the pump is being driven all the time the engine is running. On the back side of the ATF pump housing is the apply piston for the second and fourth gear brake. Whenever this piston is activated, it squeezes brake B2, which in turn holds the large sun gear of the planetary gear set from turning by locking it to the transmission case. This is the bell housing for clutch K2. It transmits its power to the planetary gear set through these engagement tabs. Anytime clutch K2 is engaged, the large sun gear is driven by the turbine shaft. Another clutch, K1, is connected to the turbine shaft. When clutch K1 is engaged, it drives the small sun gear. The K1 clutch pack is activated by this piston. It is activated and drives the small sun gear in all forward speeds except fourth. This clutch bell housing contains clutch K3. It drives the planetary gear carrier. This clutch pack is connected to the impeller shaft of the torque converter. It is engaged when this clutch is activated. So here are the three clutch packs used to transfer power from the torque converter to the planetary gear set. K1 drives the small sun gear in all forward driving ranges except fourth. K2 drives the large sun gear in third and reverse. K3 drives the planetary carrier in third and fourth. When the clutches are engaged, they transfer the power from the planetary gear set via these drive shells. This is the compact design Ravenel planetary gear set that determines the actual gear ratios in the 096. Power from the torque converter is transmitted to the planetary gear set by the large sun gear in third and reverse, and from the small sun gear in all forward gears except fourth. The power is transferred from the sun gear to the planet gears to the internal gear. The planetary carrier serves as the support for the long and short planet gears that transmit power to the internal gear. Gear ratios are determined when the large sun gear drives the long planet gears or when the small sun gear drives the small planet gears, which in turn drive the long planet gears. Only the long planet gears drive the internal gear of the planetary set. The planet carrier itself transmits power to the internal gear through this drive shaft when clutch K3 is activated. Remember that the impeller shaft is driven directly through the torque converter and turns at engine crankshaft speed. A one-way roller clutch holds the planet carrier in one direction and allows it to freewheel in the other direction. This means that there is no engine braking effect in any forward ranges except manual first. Whenever the transmission is shifted into manual first or reverse, this brake, B1, is applied and holds the planet carrier from freewheeling. The B1 brake is applied by this piston incorporated in the one-way roller clutch housing. Let's do a short review of the mechanical features of the 096 transmission. The engine torque is transferred to the transmission gears via two shafts, the turbine shaft and the impeller shaft, depending on the gear selected. 3 driving clutches and 2 holding brakes are supplied hydraulic pressure to determine how power is distributed to the planetary gear set, where the gear ratios are determined. A ring gear cut on the outside of the planetary gear set provides output to the final drive. The power from the ring gear to the final drive assembly is transmitted via an intermediate shaft. In this section, we'll take a look at components that control the operation of the automatic transmission. Let's start with the gear selector lever. The selector lever moves a cable, which in turn moves this lever on top of the transmission case. The lever is attached to the manual valve in the transmission.
The valve body determines
For every selector lever position, an electric signal is sent to the transmission ECU by this multifunction switch. The same lever that moves the manual valve also moves this cam. The cam positions contacts of the multifunction switch. This creates a different electric signal for each selector lever position. The multifunction switch also has a few functions we'll take a look at later in this segment. Before the transmission can upshift, it needs 2 more pieces of information. A signal from the throttle body potentiometer that tells the transmission ECU about engine load, and a road speed signal from the transmission speed sensor on the transmission. The transmission speed sender develops an impulse signal from a special wheel on the planetary gear set and sends it to the transmission ECU. These signals, along with other inputs, are evaluated by the electronic control unit located under the passenger's rear seat. After evaluating the inputs, the ECU generates the appropriate output signals and sends them to these magnetic shift valves in the valve body. The shift valves direct the hydraulic pressure to the appropriate clutches and brakes. The magnetic shift valves work like this. When the solenoids are not energized, hydraulic pressure is supplied through the valve to the clutches and brakes as these upper arrows indicate. When the solenoid is energized, pressure builds up behind the shift valve and forces it to the left. This relieves the hydraulic pressure to the clutch or brake, and it releases. Energizing and de-energizing the solenoids is what applies and releases the 3 driving clutches and 2 plate brakes to make the gear ratios in the transmission possible. It's important to note that any time you replace the throttle valve potentiometer, transmission ECU, or disconnect the battery, the ECU will need to be set to its basic setting with the 1551, or harsh shifting could result. Kickdown operation is triggered by this switch, which is integrated in the throttle cable. When the throttle pedal is pressed completely to the floor, the switch closes and sends a signal to the transmission ECU to initiate kickdown. A temperature sensor located near the valve body in the oil pan sends a signal to the ECU about ATF temperature. If the ATF temperature goes above 150 degrees centigrade, or 302 degrees Fahrenheit, the transmission will shift to the next lowest gear and will not upshift until the fluid is cooled. There are 2 things that the multifunction switch does that we haven't talked about yet. First, it acts as a neutral safety switch by preventing the vehicle from being started in any range except park or neutral. Secondly, it sends a signal to switch the backup lights on when the selector lever is in reverse. Both these features are controlled by a combination relay on the fuse relay panel. Let's take a minute and review some of the points we've just covered. The selector lever operates a manual valve in the valve body that directs oil to the clutches and brakes. A multifunction switch sends an electrical signal to the transmission ECU about selector lever position. The transmission ECU evaluates information about engine load from the throttle potentiometer and vehicle speed from the road speed sensor to determine upshifts. Energizing and de-energizing the magnetic shift solenoids in the valve body applies and releases the clutches and brakes. Kickdown is triggered by a switch integrated with the throttle cable. A temperature sensor in the ATF oil pan relays information to the ECU about ATF temperature. For more information about the operation and power flow of the 096 transmission, be sure to read the self-study book, Volkswagen 4-Speed Automatic Transmission, part number WSP 521-20400. There's one more important thing we should look at. That's checking the ATF level. The proper ATF level is critical to the operation of the transmission and is the first thing that should be checked before any troubleshooting is done. Make sure that the vehicle is on level ground and the parking brake is set. If the engine's cold, check to see if the ATF touches the bottom of the dipstick. If not, add ATF until it touches the bottom. Start the engine and raise the RPM, but not over 2,000 RPM, until the radiator cooling fan cycles the first time. Step on the brake pedal and put the selector lever in any gear for about 2 to 3 seconds. Return the selector lever to the park position and wait until the radiator cooling fan cycles again. Using a clean, lint-free cloth, check that the ATF level is between the marks. You can also check the ATF level by using the 1551 to measure the ATF temperature first. Apply the parking brake, place the selector lever in the park position, and start the engine. Address the transmission ECU with the 1551 and select function 09, then select channel 03 to read a value for the ATF temperature. The values correspond to the following temperatures. 2 equals 20 degrees centigrade or 68 degrees Fahrenheit. 12 equals 60 degrees centigrade or 140 degrees Fahrenheit. And 24 equals 80 degrees centigrade or 176 degrees Fahrenheit. Ideally, when the display on the 1551 is 12, the ATF temperature is 60 degrees centigrade, 140 degrees Fahrenheit. The level is between the marks on the dipstick. Well, that about does it. This would be a good time to go to the vehicle and check the ATF level using the 1551. Today, we've taken a look at the 096 transmission's general features, its internal components, controls to the transmission, and a couple of ways to check the ATF level. We hope this in-dealership training program has helped give you a better understanding of the VW 096.